am back with Small Business Tech. I believe we're up to episode 4 here. Now, I know I promised to make these a little bit more frequent. I believe my goal was to try to get to 2 episodes a month. Falling way short of that goal. I do apologize for that. However, things at the day job were pretty insane, and thus I was unable to keep up with the schedule as I had planned. Anyway, I have a pretty short video in store for you here tonight. And in this episode, we're going to be discussing switches. So, in the past few episodes, we talked about firewalls, both hardware and software. And now, if I was paying attention, I would know what else we talked about. Let's see here. We did firewalls. I do remember that because that was the last episode that we did. And 2. So 2 was just kind of a general where to start, where we discussed the benefits of some solutions in terms of hosted on-premises things of the sort. So we're gonna get into switching really quick. Enough rambling. So let's do it. So what's a switch? So essentially, a switch it's a bridge. It's I believe the technical term for it would be a multi-port bridge. Now, what sets a switch aside from a router or a firewall, the other things that we discussed, is switches for the most part only operate on the layer 2 level, meaning that they don't know or care about an IP address. They simply look at the MAC addresses in their in the Ethernet frame, and then they decide how to work. Now, there are some switches that are, as my mic falls, there are some switches out there that are layer 3 capable and can do full routing. The difference between them and what you would consider a traditional router is basically the amount of memory that they possess, which greatly limits how big the routing table can be. But people can and do use switches as routers. In fact, in my day job, we use switches as our WAN routers between our multiple data centers, and it works quite well. So back to the main point here. Switches, like I said, they work at the MAC address level. They don't care about an IP address. Basically, the way it works is you send traffic in one port. The switch looks up the MAC address header in the Ethernet frame, and based off of that, it decides which port to forward the frame out of. If it doesn't know what the MAC address is, then it just floods it out of all the ports. It's simple as that. And based off of that, it will learn where all the MAC addresses are. And keep in mind here, a MAC address is just is sort of synonymous with an IP address. It's not directly. It's don't write me any bad emails about this. I know they're not one-to-one, but for the audience that I'm targeting here, it's relatively synonymous, right? So you have one MAC address equals one device. The same way, one IP address equals one device. Now, that's not including NAT and a bunch of other things, but again, for simplification purposes, one MAC address, one device. So they're most commonly used to extend your network. A common thing would be, say you buy a router from Best Buy or wherever. They typically only come with 4 ports. Yes, they have Wi-Fi, but what if you can't use Wi-Fi and you have 10 computers in your business? Then what do? Well, you'd connect a switch to one of those ports on the router, and then you'd connect your whatever the overflow of devices is. So I guess you'd be able to connect 3 plus a switch to the router, and then you would just connect the other 7 computers to or printer or whatever the case may be to the switch, and that way they extend the network. One other thing I should mention is switches can also be used to power other devices. There is a protocol out there called Power over Ethernet, and it is commonly used to power devices such as cameras. And the more common usage that you would tend to see would be to power wireless access points. Now, the benefit there is that you, instead of having to run two cables, right, one for power, one for network, you would just run one, right? So basically, what it does is it uses some unused pins or frequencies on the same cable to basically provide power. And how much power it can provide is all in the spec, and how much power the powering device, in this case a switch, can provide is up to the switch specifications. At the end of this video, I have a short little unboxing here of a little 8-port switch that I'm currently using in my home, and it's only 60 watts, so you, in theory, can power 2 or 3, maybe even 4 wireless access points, but not much more than that. So let's keep it moving. So basically, the speeds the switches come in are, they're laid out here, right? So some really old technology, which technically aren't even considered switches. They would be more or less, they are hubs, but also older devices, still, like really old. I'm talking about 1991, 1992 devices can still support 10 megabit connections. Now, seriously, no one should ever be using this, but it's worth mentioning in the video. Then there is the 100 megabit Ethernet, which was pretty popular in the late 90s, early 2000s. It's also known as fast Ethernet. So if you ever look at a switch and it says fast Ethernet, this is what they're talking about, 100 megabit. Now, the more common and more modern speed is what we call gigabit Ethernet, or 1000 megabit connection. Now, any modern computer made in, say, the last 4 to 5 years that has a physical Ethernet port will come with and will be a gigabit port. Any router is bought in the router or the firewalls bought in the last 4 or 5 years will probably come with a gigabit Ethernet port. There are some devices, modern devices, that still don't use gigabit Ethernet. A good example of that would be a Raspberry Pi. But for the most part, 1 gigabit is the standard. So now, the next speed up from that really would be 10 gigabit Ethernet. Now, a few years ago, 10 gigabit Ethernet was crazy expensive. These days, it's a little old because of its age. It's a little cheaper, and it's actually coming down market to more prosumer and consumer level devices. So you can possibly, I've seen some Netgear 10 gigabit switches for about $300-400 on eBay. On Amazon, where not that long ago it would cost you $1,000, $2,000, maybe even more. Keep in mind, some 10 gigabit Ethernet adapters are still relatively expensive by comparison. So one of my favorites is the Intel X520. That is a 2-port 10 gigabit Ethernet adapter, and I believe those are still selling for about $200, $300. Now that uses the SFP Plus connector, which one of these days I will make a video to show the different connector types. But for now, it's SFP Plus, and but they do also make 10 gigabit switches and Ethernet cards in the standard RJ45 format. It's just you use a much higher quality cable. Then the next one up would be the 40 gigabit speeds. Now, 40 gigabit Ethernet is more or less new-ish. I mean, there are a lot of businesses, even large businesses, that don't have 40 gigabit connectivity, and the ones that do tend to use it within their data center, switch to switch, things of that sort. Still relatively expensive, and uses a different connector that is not come down the price yet. So I don't expect anyone to deploy something like this in their small businesses. And last but not least, I believe the current new hotness would be 100 gigabit Ethernet. Um, I have not seen this actually deployed in any businesses. The closest I've seen to this would be where you would bond multiple interfaces together to get 100 gigabits. So, for example, you would bond, say, 10 gigabit Ethernet ports, or something I've seen a lot is where people would bond a couple of 40 gigabit ports, and to get 80 gigabits out of it. 100 gigabit is definitely more of a ISP level thing. So your big players like Verizon, Level 3, those guys will deploy 100 gigabit, and that's just because of the amount of traffic that they pass. Again, not something that you would typically see in a small business or even a medium-sized business, and certainly other than the extremely large enterprises, you won't see this in there. So, as usual, I like to end these videos here with a quick look at some switches. So this here is it's a Netgear switch. It's they consider a smart switch. Smart switch meaning that you can do some management to it. There's a little web GUI that you can go into, and you can tweak a few settings here or there, but nothing crazy. But probably enough for a small business. This is only an 8 port model, so you're depending on how many connections you need in terms of computers, printers, things of the sort, this may or may not be enough for you. So one thing I should do before I advance to the next picture here is to mention one thing. So modern network devices have something they auto negotiate, right, to whatever it's the highest agreed upon speed. So if you look at the picture here, it says in the front picture there's says 1000 m, 100 m, and 10 m. So what that means is if you plug in a device that only knows how to operate at 10 megabits, then the switch will automatically downgrade the port speed to 10 megabits. Likewise, if you plug in something like a Raspberry Pi 3 or even say an old Xbox 360, those are 100 megabit devices, and again the switch will see that and will automatically downgrade the port speed to 100 megabits. If you plug something in that's gigabit or 1000 megabit capable, provided that you have a cable that I believe is at least Cat5e rated, or maybe just I believe Cat5e, you will get the full gigabit speed. But no, if you plug in well, I mean, I guess it goes without saying, right? So if you connect a 10 gigabit RJ45 connection to that switch to a 10 gigabit server or computer, you will only get 1000 megabits, right? You only get the 1 gig speed because that is the I don't want to say physical, but as it is the electrically possible max speed of that interface. I know I worded that pretty badly, but it's I'm trying to speed things along here. So moving on, this is more of an enterprise level switch. As you can see, this is a bit of a mix here. So you have, I believe, 48, maybe 40 or even 48 1 gigabit copper interfaces. Those are the ports that look like any other port that you've seen in when you look at the switch. For example, all these ports. And if you notice at the top left there are 4 little square looking, funny looking holes. Those are actually for SFP or SFP plus modules, right? So that's basically where you connect fiber optics to. And depending on the speed of the interface, and I believe these were 10 gig, but don't quote me because I didn't actually look this up. I just kind of browsed the internet for some pictures that I could use. But assuming these are 10 gigabit interfaces, you can basically connect a fiber optic module and connect some fiber optics, and you can be off to the races doing 10 gigabits. And as usual, I like to throw in the large end of the spectrum. This is a true enterprise class device. In fact, this basically only does 10 gigabit Ethernet. As you can see, there is no 1 gigabit switching plane here, right? So there's no RJ45. The RJ45 that you see there are not for switching in the sense that you would think of. They're more for management. There's like a management interface that you can address the device by and do some configuration changes and things of the sort. Again, this device is all SFP or /SFP+. Now, I'm running a little longer here than I wanted to, so I'm just going to play the unboxing video, and then I'm going to call it a day, or call it a video, and we'll see you guys relatively soon. Alright guys, so here we are. This is the Ubiquiti UniFi Switch 8 60 watt version. It's going to be my my first attempt at an unboxing. So what this is basically, they say it's a managed switch, and to be honest with you, I've never used Ubiquiti switches, so I don't know that it's a true managed switch. But it's really, it's what it is it's controlled by the Ubiquiti UniFi controller software, which I was supposed to show you as part of my firewall episode, but somehow or the other I forgot, and I'm not going to go back. Maybe if I do an episode on Wi-Fi, I'll show you that then, but no, until then. So there's a simple 8-port switch, power in the back. The last 4 of these ports do power over Ethernet. It's 802. It's AF. 802.3AF power over Ethernet. That's the standard that Ubiquiti uses for their access points, meaning that you can connect your access point directly to this and get power from it. And you know, it's not really a lot in the box. The place I bought this from on eBay, brand new, was somewhere in Eastern Europe, I guess. So hence why I have the European power adapter. But if you look, this on the power brick, it's just a standard C14, C13, and I can never remember those numbers. So basically a standard PC power supply, power cable will work in here. So that's it. And that's the end of this little unboxing here. That's the end of our the end of our video. As usual, if you guys have any questions or comments, feel free to hit me up on the YouTubes. And for now, that's the end of this video. See you guys next time.